Suman, I'm curious. How do you build an autonomous truck? I know you don't go to the Lego store or the Tonka truck store. How do you really build an autonomous truck?
Grayson, thanks so much. Greetings from Portland, Oregon. First of all, thank you for having me on your podcast. I always enjoy listening to your perspectives, and today I get to share some of mine. On your question, how does one develop autonomous trucks? First, the key is to acknowledge a couple of things, Grayson. The first one is it has never been done before. So we have to be patient and rely on our past experiences and be open for collaboration, especially so that we can harness new emerging technologies. So that's number one. And number two is it is going to be filled with challenges. Some of these challenges may absolutely seem too hard to address, but we must address them because this is the single most significant opportunity that we have to address highway safety. Every year we lose about 5,000 lives due to Class 8 truck accidents. And now we have an opportunity to add to all the safety suites that we have to also have a level 4 autonomous vehicle. So those are the two things that we have to acknowledge. And when you ask this question, how do you build an autonomous truck? I want to give a little bit of perspective on how Daimler Trucks North America has done this in our own development process. Our journey to pursue something in the level 4 autonomous started in about 2018 is when this idea came about in our product strategy group. And until then, we had worked on safety in general. We have had our experience in introducing ADAS suites, so SAE level 1 and even SAE level 2 ADAS systems. You may remember in 2019, we were the first one to introduce the SAE level 2 Class 8 truck in North America. Engadget at CES 2019 recognized that as best-in-class transportation technology. So we have some experience over the years developing features, developing software and hardware features in form of driver assistance. While granted, SAE level 1 and level 2 requires a driver behind the wheels all the time. But our commitment to safety started off much before 2018. And then for a very brief period, we dabbled in SAE level 3. This is when we were trying to see if we could have platooning as a way to not only enhance highway safety, but also offer some solutions in terms of freight efficiency. Very quickly, we realized that that is an area where we were not able to prove a lot of value to our customers. So we indefinitely shelved that and started looking into SAE level 4. And that is where we are right now. And here we are talking about an SAE level 4 vehicle platform that does not require a human to be behind the controls. Instead, the vehicle is perceiving the environment, it is localizing itself to some high definition maps, and it is able to have a behavior planned already, and then it is relying on the vehicle to safely and reliably execute that within those operational design domains. And that is our journey that we have been on. This is like year 5 into this journey that we had embarked on within Daimler Trucks North America. And all I can tell you is that if you want to ask what is one formula that we want to develop an SAE level 4 vehicle, we must have good partners. At one point of time, Daimler always thought that we can develop these solutions in-house. So even if you look at our ADAS journey, we developed our ADAS suites in-house. At some point of time, we had to acknowledge the fact that the level 4 endeavor is not an evolutionary step from SAE level 1, 2, 3, and 4. It requires a whole paradigm shift. And then we started looking into these partnership with companies that are very good at robotics, partnership with companies who understand AI and harness the power of AI so that we can have a product called a virtual driver or a self-driving system software, which will rely on a very, very robust vehicle platform. And that is a piece that I bring to the table where my team and my department, along with our suppliers and collaborators and partners, is to bring a very robust vehicle platform, which can act as a faithful actuator so that any self-driving system can command it to embark on a journey from point A to point B without having to depend on a human behind its controls. So to summarize it, how does one develop a level 4 system? Acknowledge that it is going to be a long journey, rely on partnerships because we're going to need that. And above all, make sure that safety and reliability of the vehicle platform is something that we want to consider as a foundation for it. it.
In 2018, you hatched the idea. What was behind the hatching? Was it a brainstorming? What caused the idea? Was it business economics? What caused that?
I think it was a combination of business economics, knowing that this is going to be one large opportunity for us to look into, especially when you create a solution that has a potential to generate revenue even beyond point of sale. If you think about it, Daimler relies heavily on revenue generation at the point of sale when a truck is sold. And of course, after that, you have ways of generating revenue through aftermarket and such. But when you think about it, a revenue potential when every mile the truck drives in a certain autonomous mode, you have the potential to generate a revenue. So that's a huge attraction. When you're able to build on that, the fact that our commitment to safety can also be fulfilled. We have always been wanting to provide solutions for highway safety. And there is a vision at one point of time, people were even afraid to whisper, what if there was zero fatalities on North American highways? And now you see that people are no longer afraid to call that a vision. Yes, it is daunting. It's big. It's probably going to take a long time. However, it's a rare opportunity where business economics, how attractive it is to generate revenue even beyond point of sale, mixes with this desire to attain an accident-free highway and, most importantly, a fatality-free highway. And that makes it worthwhile to pursue.
Looking back in history, winding back the pages of the history book, was 2018 the right time to launch this? Do you think you hit it right? Were you too early, too late? What do you think, looking back in retrospect to when you launched the autonomous truck program?
If you think about it, at that time, in 2018, from my perspective in North America, ADAS was still, or advanced driver assistance safety, was still a burgeoning area. It had not fully proliferated into the market yet. If you look at the adoption rate of ADAS systems back in 2017, 2018, it was probably less than 50% of Class 8 trucks sold in North America, new Class 8 trucks sold in North America. The customers would have opted for ADAS functionality. This, I'm talking about adaptive cruise control and automatic emergency braking. Nothing fancy at all. Things that we take for granted in any new car today. That was not at a high take rate back in that time frame. So I would say we as an industry were also learning the capabilities of what the sensors, what the actuators could do in the field of ADAS. And we were also scratching the surface of what would level 3 automation look like. So there was definitely a curious phase, a very explorative phase right now. Would the industry be ready a few years earlier? I don't think so from where I was seeing the adoption rate of ADAS. So I want to say that we had to prove to the market that we are able to do basic things like adaptive cruise control that helps us maintain a safe following distance, an automatic emergency brake, which autonomously triggers a braking aspect within a vehicle to protect the driver from an imminent collision. It was important for us as an OEM and the industry to prove to the market that we can reliably do such simple aspects in a Class 8 truck. And therefore, I think the time was not too far off from an ideal state, I would say.
The market was starting to evolve and mature. Then you had the work coming out of the Defense Department for off-road vehicles, and you needed the development time as we're seeing today. You said a really great line. It's never been done before. I'll use the term as a Herculean task. You had this big leap of faith that you had to take in front of you. Once the strategy was set and says, okay, Daimler Truck North America is going to build an autonomous truck, what was the first thing you had to do?
I remember when I took on this responsibility, my boss back then, Dr. Wilfried Achenbach, and he had given me this task. It was one of those tasks where you don't really have a blueprint in front of you. You don't even have a full-fledged team in front of you. And then this is built as a skunkworks or an incubator within a large organization like Daimler. So the rules are slightly changing, yet you still need to speak to the rules of the larger organization. So all those elements of volatility, uncertainty existed at that time frame. But what was crystal clear in his commitment to me and my commitment from that point onwards was to dream and build the best dam level 4 Cascadia. And when he said dream and build the best dam level 4 Cascadia, there were some elements of it that are very subjective and that kind of create those emotions and wanting to figure out, as you said, the Herculean task. It is a Mount Everest of a challenge. And the fact that you have never done it before and there is no blueprint makes it very interesting. However, there are some common elements of it. In order for us to achieve a level 4 product in the market that can truly go beyond a demonstration or even a small pilot. Instead, it is rolled out, trucks coming out of our plant, being serviced in our aftermarket network, and actually providing value to a customer that they can look in the bottom line is to make sure the product is reliable. And that's when we start relying on the organization's traditional, conventional knowledge. We really need to start defining who's doing what. And I'm going back to the first principles in taking on a project like this is I had to build a team and set a direction for them that had to have certain boundaries. I am not trying to design the software that is managing behavioral aspects. I'm not trying to design a team that is working on perception problems or localization and mapping problems. Instead, I'm going to have to build a team where the primary focus is to build a level 4 vehicle platform. I need to figure out what those guiding principles need to be because this is the first time we are developing a truck that needs to not only respond to humans outside of the operational design domain. This truck needs to be a best product for the human, but also be able to fulfill all the requirements coming from a virtual driver. We had to start using a vernacular within the department. Are we talking about a human-driven truck or an autonomous truck? So that's a whole paradigm shift also for us. So the first thing we had to do was to define what role we have to play in this Herculean task. As you said, it is important to have that because that sets us in a firm direction and others can rely on us.
Dreamed. The dream's coming true. You're building the best damn level 4 Cascadia the market's seen. Your customers speak highly of it. Your partner speak highly of it. The suppliers speak highly of it. When you're going through this dream and you're sitting there and you're imagining this dream, where does design come in? Because obviously when you go to SAE level 4, you could technically eliminate the cab, but when you do that, you're going to have to build redundant systems. You have to build cooling for the GPUs. And I was reading a report from a bank today, Amazon's AWS is growing faster for their own chip architecture than NVIDIA's chip architecture. And NVIDIA's down 8% today as we speak right now. The market's selling off. The market's correcting itself when it comes to GPUs. Obviously, that's going to affect the design. How do you put all that into, I'll use a kid's term, you put it into the potion to make the dream come true?
It's a great question. And I often get asked in a very friendly jab way from our customers is when I showcase the autonomous ready Cascadia, you see behind a 72-inch sleeper. And right away, people are like, wait a minute, that is the largest cab meant for creature comfort. And some people call it the apartment. And aren't you supposed to be driving without a human behind the wheels? And the simple answer is we wanted to start with a vehicle platform, a cabin, and an entire tractor configuration that is known to us, that gives us a little bit of flexibility in packaging, that gives us a little bit of flexibility during the early stages of development where, there is a safety driver, there is a safety conductor, a lot of data acquisition systems, and also some folks at the back monitoring these systems. So to fulfill the need for more real estate during the early development phase, we picked a cabin that was what I would consider as an easy choice, while acknowledging right away that the customers in the market are going to ask this exact question. As these systems become ready towards market and launch, there will be a question in terms of why do we need a sleeper? A first question can be, why can't we do it on a day cab? Now we are talking about a cabin that is a lot lighter, a lot less expensive, a lot less complicated. So those are some questions that we are asking ourselves internally. As a first step to starting to answer, what does it mean to package all the complex perception sensors and the computes required for a level 4 autonomous vehicle onto a day cab? We took on a challenge and we said, we're going to build a technology demonstrator. And the purpose of the technology demonstrator is going to be multifold. One of that is going to be, can we even package it on a day cab? How would that look like? What are the benefits of it? As soon as we started doing that, some of the larger organizational support within Daimler Truck started asking the question, can we envision a cab which is not requiring a human to be inside it? And there are some sketches. Our product designers have gone and dreamt their version of what this could look like. They're all in an early concept stage. And the question on, do we even need a cab? I believe that one of our competitors had envisioned that in Europe, where the entire trailer is being moved by a skateboard-like design. There are some incarnations of that in our drawing boards, but Trust me, we're asking those questions, but it's going to take a little bit of baby steps, I would say. The 72-inch raised roof sleeper gives us an opportunity to go out there and learn. And I always tell this to my department here. This will be known as a decade where we all learn, and then we are going to look back at our first launch and say, how can we make it better? How can we make it more efficient? And then the second incarnation of this could be something like a purpose-built day cab, analogous cab, before we see something more dramatic. Because if you think about the cab design in any of the Class 8 trucks, there are a lot of commonality that we want to also synergize from. Anytime we tool something large, we want to make sure that we have adequate volume to back those tools. So you would see the first couple of incarnations of this benefit a lot from existing tooling and existing ways of putting these vehicles in our high volume plant.
If you look at the high volume and you take one of your customers, for example, just out of respect, we'll call them Acme Fleet. Could they technically or legally buy the autonomous ready Cascadia today, use it for traditional hauling, not with the autonomous features, and then when it's ready, send it back to Daimler for retrofitting on the factory line, and then they've already amortized the cost? Is that a potential possibility?
Not currently, because the current status of an autonomous ready Cascadia is such that it is still going through the development phases. In the automotive lingo, we would call it somewhere in the C-sample maturity. So it is not yet ready to be released for full production from a plant. But we started building these vehicles in our plant so that we start understanding what it means to having the production plant. We have about 5 production plants all around the North American continent. We have 3 in the US and 2 in Mexico. So we are exploring what would be the ideal place to have this in volume, acknowledging that the first couple of years, it'll be a slow ramp up. The model will always be that once we are ready, once we do all the FMVSS, all the FMCSA regulation, and when we have the powertrain certified for the appropriate emission level, we can say that the truck is ready for a full start of production of the plant. Our initial business model is always looking at the truck being sold through our point of sale with all the perception sensors, if it is with Torque Robotics built at our plant. And we also have the ability to offer these autonomous ready Cascadia to a partner like Waymo, where the installation of perception sensors and compute will be done at their end, where our responsibility is to release a vehicle that is qualified and certified to be autonomous ready, and any kind of post-production installation is done by the autonomous driving system provider, for example.
If we were having this conversation 2 weeks ago, I want to make this remark. I was shocked in San Francisco Standard, Waymo's PR. This was on the record statement, said VIA is on the thing to come back, which is very, very interesting of what that opens up to the market. So if you think about this as potential, it's on the record in the San Francisco Standard. You can read it in This Week in the Autonomy Economy newsletter. It's on the record. They're going to need a longer development time to get to where they were and to where the industry is. And during that time, propulsion could change. We can go hydrogen. We can go all electric. We can go hybrid. We can go diesel. Maybe there's a new technology breakthrough. What impact are all these propulsion breakthroughs having on the development of the autonomous ready Cascadia?
That's a good question. And this is where I would probably want to go back. In 2019 or so, when we embarked on this, we wanted to put some guiding principles. And one of the guiding principles wanted us to be agnostic to what propels the truck and who drives the truck. And the term agnosticism is used quite a bit in this industry. And for me, when we coined that terminology to be agnostic to what propels and who drives, translates to freedom to the customer. So when my responsibility as a technology originator embraces the concept of agnosticism, that translates by the time the product is ready for consumption to a customer as a freedom of choice. And propulsion is a good example. Our entire architecture for the autonomous ready Cascadia takes care of a lot of redundancy in brake, steering, low voltage power net and all. But we also wanted to design in such a way that the controller, we call it the common powertrain controller, which takes care today of the diesel engine, all the requirements that is needed for the diesel engine, the transmission, and any after treatment topic. So we have this common powertrain controller that is able to take in an acceleration request and abstract it to how best you can deliver it to the wheels through all the propulsion systems that exist in an internal combustion engine vehicle. Now we have taken that logic and we want to prove in this technology demonstrator that we showcased in Las Vegas at ACT an electric Cascadia. That's the first time that we are having that interface moved to an electric Cascadia. And that was a big step for us to prove it out because until now, our experience in moving something that was developed for an internal combustion engine to an electric engine has been in the field of ADAS. We were able to abstract adaptive cruise control logic very easily from an internal combustion engine to an electric vehicle because of our common powertrain controller. So we're using a similar framework also for the autonomous ready Cascadia. So once we are able to address an internal combustion engine logic, which requires us to understand the engine, the stoichiometry within the engine, and how it translates to a transmission all the way to the axles, we are able to learn from that and apply it to a hydrogen engine, internal combustion engine, because essentially they are internal combustion engines. Now you take the new effort that we're doing with the electric Cascadia technology demonstrator, whether it is a battery electric vehicle or a hydrogen fuel cell powered electric vehicle, we're able to take the findings from that and apply it. So our purpose is to have that portfolio of propulsion systems, alternate propulsion systems, covered through our common powertrain controller logic. So that way we're able to abstract any request for acceleration coming from the self-driving system or the virtual driver and be able to execute it regardless of what propulsion system is used in the vehicle.
It's a great hedge. No matter which way the market goes, you'll be able to offer an autonomous ready platform. That's a game changer. How did you develop that?
Going back to the fundamentals, so it was a very important step for us in 2020, 2021 to sit with some of the best players in the industry to collect what we would call as functional objectives or requirements as seen by a virtual driver to what the vehicle must fulfill. So we had these early stages on what should it do. On a very early stage, we said, well, let's make it a robotic truck, which means that you could drive it by wire. And yes, that did give us a great starting point to understand what are the challenges when it comes to controlling the vehicle in terms of lateral and longitudinal aspects. Then we started deep diving and approaching it from functional objective across multiple systems. And this was a very important step for us because it made us come up with a very simple philosophy, which is we must provide, from the vehicle's perspective, all relevant vehicle health information and controllability as good as or better than what a human gets from a vehicle today. So I'll repeat that. Our guiding principle would say we should offer a vehicle whose vehicle health information and its controllability as good as or better than what's available to a human today. So once we were able to pen that one out, it became a line that we would often refer back when we were crafting out these functional objectives together with our industry partners. These functional objectives helped us solidify certain directions that we had already planned until then, but it became more apparent. For instance, how does one ensure that the vehicle is always controllable from a braking perspective? If you look at today's design, all our braking systems must have a pneumatic backup so that even in case of an electric or electronic failure in our ABS module or ESC module, the human driver has basic controllability of the vehicle so that they can bring the vehicle to a safe state. Now you take that fundamental principle and now look at it with a virtual driver in command. And now that's when it became very apparent to us that we must have certain level of redundancy built into the system so that it can act as if what a human could do in case of an electric or electronic failure. So that became our, what I would consider as a grounding point. Anytime we had a question on how would we go about designing the steering system, we went back to a similar question. What would a human do today if there's an electric failure in the steering system? Well, they have the pneumatic backup or the hydraulic backup that gives them some controllability. But what if there is even a hydraulic leak and you lost all the hydraulic fluid? Then the question is, well, you rely on the human's muscle power at that point. Yes, it is hard, but then the drivers today can control the vehicle and bring it to a safe state. That translated us into us working with one of our most revered suppliers to making sure that we designed our steering system in such a way that we had the right level of redundancy, even in case of not just electric failure, electronic failure, but also hydraulic failure. So system by system, we started looking into this and asking questions on what is available to a human today? What health statuses are we broadcasting today to a human so that they know that their vehicle and its capacity is always known and understood by them so they can operate within those limits? we want to be able to provide that information to the virtual driver or the self-driving system. And same goes with the controllability. So that became a very nice way to ground ourselves when we got too carried away.
What is the right level of redundancy? Is it mission critical, has double redundancy, triple redundancy? What is the right level of redundancy?
The important part about redundancy is to once again go back and ask, what do customers want today? The customer's expectation here today is safety and making sure that we complete the mission. So if you think about it in that order, we have designed all our redundancy around the first key attribute, which is safety. And this is one of those areas where we would need to take the first step to addressing the redundancy addresses safety of the vehicle. And then we need to see what kind of impact it has over a period on the operational efficiency. So we have designed our vehicle in such a way that I'll take an example of low voltage power, for example. The truck has an alternator, and all our trucks are at 12 volt architecture today. So it has a 12 volt alternator, which is driven by the engine through a belt drive. Very simple. Should there be a damage to the belt today, and that results in the alternator unable to generate any power by itself, today a human driver has to pull over because there is no way the human driver has capacity to address that specific malfunction or an error. So we thought about that, and knowing that we must account for all the systems consuming maximum power and we really can't pull over anytime there's an alternator failure, we came up with a number, about 20 minutes of stored power, assuming that all systems are firing at their maximum load. That became our guiding principle on we must design a vehicle to at least be able to have enough stored power in it so that for 20 minutes it can go without an alternator generating any power at all. And of course, you might ask, like, where'd you get the 20 from? And there were some discussions early on in the project where we said, like, well, the likelihood of something like this happening is low, but it is not zero. But should it happen, the one thing that we want to avoid is not be able to attain a safe state. Attaining a safe state in case of an error in the vehicle, we refer to it as a minimal risk condition, or in order to get there, you execute a minimal risk maneuver. Think about it as safely getting to a spot, whether it is to the shoulder, side of the road, or take the nearest exit and find a safe spot. All of that is determined by the virtual driver and its capability of assessing the mission and all those spots during a mission. But the vehicle must be able to support all the systems. So imagine that the steering system is not compromised for power. LiDAR and the compute is not compromised for power. And the entire vehicle's electrical consumption must be taken into account. All of that, considering all of that, we said 20 minutes would guarantee us that we will be able to safely pull over. And that information is always available to the self-driving system. And the self-driving system must make the right decision at that point. Our job is to provide the residual capability of the residual capacity of the vehicle so that the self-driving system can assess that and do the right thing. Very similar to what a human is expected to do today when they get behind the wheels. They must know the condition of the vehicle, they must know the capability of the vehicle, and make sure that they can follow the safety of themselves, people around them, and the goods that they're carrying. So we expect that kind of a responsibility also from the self-driving system.
Is it a separate source of power that you're pulling from for that? Is there a separate battery inside of the truck that turns on automatically in case of an emergency or a failure?
The low voltage power net system, we call it the low voltage power net system in a truck because the high voltage is used for battery electric that are operating at 400 volts. So when we say low voltage, we're talking about an alternator today in a human-driven Cascadia, which is a 12-volt alternator that is catering to all the electronic control units in the vehicle. When we started developing the autonomous-ready Cascadia, it became very apparent that the high-power computes are going to require a lot more power. And early on, this was one of the biggest challenges that we had to solve. I would say it was a fun problem to have, and I'm glad that now it's behind us because we were able to pick a direction and stay focused on that direction. So we knew that we had to support 3.5 kilowatt to 4 kilowatts of additional power at its peak that will be consumed by the self-driving system's computers, the high-performance radar, LiDARs, and cameras. So very quickly we realized we need to do something about the power generation. Yes, we can add batteries, but it is more important to generate power to continuously be able to feed to these high-performance computes. and other self-driving system sensors. So we looked at a few options, and we are very happy to say that we picked a path which works best for us, which is to generate at 48 volts. So this is where it gets interesting. We designed the whole autonomous ready Cascadia around a very service friendly design. So when someone opens a hood and looks at it from the hot side of the engine, which is on the passenger side of the engine, you would notice an alternator. Today in a human driven Cascadia, it's mounted onto the engine block. And under the hood of an autonomous ready Cascadia, it's still exactly in the same spot. In form and fit, it looks exactly the same, but it is a 48-volt alternator. And you can identify it by the blue cable that comes out of it. And that generates at higher voltage. And then we are able to distribute that across three high performance and high integrity low voltage circuits. We call it low voltage circuit A, B, and C. Low voltage circuit A and B are reserved for redundant systems. So think about it as they're dedicated, and they are two dedicated low voltage circuits that are feeding to the computers, the LiDARs, the brake system, which requires redundancy, and the steering system that requires redundancy. So those are the high value redundant power net systems. And low voltage circuit C is reserved for non-redundant systems. And we also increased the battery capacity of this vehicle. A traditional human-driven Cascadia has about 8 batteries. In an autonomous-ready Cascadia, we have packaged 4 extra batteries, and all these batteries are diversified in such a way that the critical systems are always getting uninterrupted low-voltage power supply for them to have redundant power source.
When you were designing, and you're continuing to design and refine the design, when did maintenance enter the picture of the technicians being able to work on these trucks without having to go back to school and learn how to operate or repair a whole new truck?
Yeah, one of the early stages of this project, actually our first, one of our earliest employees is a person named Van Solberg, came with a rich experience having worked at the plant, and he has hand-built prototype trucks. And to me, I always remind myself and remind him whenever I see him is, I am replaceable in this project like this. He is not, because it was very important to have certain technicians understand this truck and give a very valuable input. And yes, we had to relearn certain attributes of how to design and release a vehicle. And one of my managers spent the last 5 years together with me designing a very strong crew of vehicle technicians who build the vehicles and harness technicians who make sure that the harnessing of these trucks are at a whole other level compared to what is needed on a Class 8 vehicle, because you cannot afford to have a harness compromise your redundancy strategy. So we have a very important group of people who developed mechanisms and processes to ensure the harnessing on these vehicles are something that we can rely on. And of course, the commissioning and software commissioning experts. So very quickly, if you look at it, it's people bringing in their skill set, and they would give feedback saying, it's a very bad design. You can build one prototype, but if you're even remotely thinking about having it roll out of the production plant, you better go back to the drawing board, because there's no way you can make several hundreds a day if you were to keep this design. So a lot of humbling moments, from both sides, because at one point of time, we had to very clearly say, if this truck can be depended on by the virtual driver to drive without a human driver, that translates to how it is built and how it is serviced. So we need to make it service friendly and manufacturability friendly so that the end result can be on a very solid platform. And at one point of time, we even coined this term. There was a time when we used to say blue collared and white collared, and we started calling some of us as we are the new collar employees, because this is new. This is a new collar environment where we need to make sure that it's no longer someone who turns the wrenches, who doesn't really care about how the parameterization on an ECU is, and vice versa. Just because someone's working on a parameterization of an ECU, they don't care about how it is installed and serviced. So we started creating this mentality of a new collared environment, because whatever we are doing is so symbiotic. We need to really work together, and a great deal of respect for my technicians. Without them, this product will be a great prototype, not ready to go into a production line, I would say.
Prototypes don't make money. That's the bottom line. Factory designed trucks that get shipped make money. I like the line that you use, new collar employees. You're right. And the important aspect to highlight here is autonomy is going to create jobs. All these new jobs from your platform alone, from an engineering perspective, from a service perspective, maintenance perspective, sales perspective, is going to create lots of new jobs. Staying on the topic of design, I'm curious. When are the mirrors going away, and what happens when the side view mirrors go away?
You can already see several trucks out there today with mirror cameras. And if you remember a few years ago with Super Truck One Challenge, you may remember the Super Truck Challenge that the DO poses to all big players. Our Super Truck One looked at this option of reducing the mirror dimensions to a bare minimum. I don't know the exact number. I think it's 50 square inches of mirror surface. That's a bare minimum. And we added the mirror camera to say that it's possible to have an aerodynamic benefit while still maintaining what's required from FMCSA to have a mirror. And if you fast forward now, the Super Truck 2, which is a really good way of us to have some trickle down effect from such technology demonstrators down to actual products. Super Truck 2 did not have even that small 50 square inch mirrors anymore. Super Truck 2 was just a mirror camera setup. And you can start seeing NHTSA also opening up to some of these possibilities. And I think right now we don't have a blanket rule that you can operate without mirrors. I think there is still some kind of an exemption that you must have for a limited volume to test and prove the value. Definitely measurable aerodynamic benefits come when you take that surface off. Definitely advantages in terms of what the driver gets, especially you can have a lot of overlays on those screens. My first time driving a mirror cam equipped system was actually in Europe. At that time, I was responsible for level two systems and I was testing a Cascadia, believe it or not, in Europe. And during one of the rotations, I had to sit in a Mercedes Actros. And I remember driving that vehicle for the first time. And during daytime, I didn't really appreciate the mirror cams that much, saying that I still get a better depth perception when I go to my actual mirrors. That was my position. And that changed 180 degrees when we hit dusk and we started entering an unfamiliar area to stop for the night. Because I found myself now looking at the screen because the screen had so much rich information at low light, and you're able to have so much information overlaid on top of it. So it took me less than 3 hours to say, like, this is what is needed for safely operating for someone who's looking at their trailer and someone who needs to navigate through urban traffic. So the benefits are pretty clear. We're going to see more of it. And now you can start thinking about how ADAS can benefit, advanced driver assistance system. How can they benefit from some of this? How the video capture facility can also help fleets take care for either driver training or litigation. So I think the benefits of mirror cams are huge. We know that there are measurable benefits. I don't know what percentage would that be, but it is definitely measurable. Now we just need to prove to the policymakers that yes, in fact, it is reliable and you can count on it. Because at the end of the day, that's our responsibility as technology originators. We must show to the legislation and also to the societal aspect of it that these technologies are reliable. It goes beyond just a proof of concept or a prototype. So that's where we are on it. The autonomous ready Cascadia still has traditional mirrors because we are designing it also for a human driven condition. But think about it as a first incarnation. We always want to start with a technology that already exists, and we do small changes to have the dependencies not burden us down. But you can expect that to evolve.
When the mirrors go away, how do you see the sensor suite changing? Does it become more reliant on camera? Does LiDAR still play a role? Does the positioning of the sensors? Obviously, it's going to change because you're not going to the side view mirrors. But overall, how do you see that changing?
We rely heavily on the self-driving system partners to define how they would like their perception suite defined. So currently, as you know, we work with two self-driving system providers. Both of them have very unique approach to their perception suite and how they would like to design the perception suite for their self-driving systems. And both of them use a combination of radars, both short range and long range, LiDARs, both short range / mid range and long range, and an array of cameras. So this combination of all three sensors, all three sensor families coexisting, I think you would see it for the first iteration of it. And it's conceivable that each of them will have their own for the first product, because I think all their self-driving software is developed around a very specific placement and very specific input coming from these. Once again, someone might ask, like, is there any value in standardizing? Is there any value in looking into the future? But the climate as of now is every self-driving system is depending on its own perception suite. And now my responsibility is to make sure I understand with whom we are working and making sure we integrate them into the vehicle in such a way that it meets any FMCSA width regulations and height regulations. It is important that we make sure it is serviceable and it is protected against the elements so that the perception element of it can be guaranteed for the self-driving system to do any computation that it requires. So yeah, the first step is each self-driving systems come with their own perception suite, and our job is to integrate them in such a way that they can always rely on it.
How do you prepare for the future? The perception suites are changing. If you look at Waymo on the passenger side, they came out with the latest version of their driver. The suite is dramatically changed. If they do launch VIA, that will change. Your other partner suites are continuing to change. And then there's a big debate brewing, and it was mostly led by Elon Musk, that LiDAR is going away. We're seeing less and less redundancy and reliance on LiDAR today. What happens if the entire sensor suite changes? How do you adapt for that?
I think most important aspect of adapting to an evolving sensor suite is to take that into account when we are designing our cabin. So if there is a next generation cabin that we are working on, having these in mind helps us a lot. And I'll give you a very concrete example. When we started working with one of our partners, the entire sensor suite was required to be mounted onto the roof of the cabin. So you may remember on a human-driven Cascadia, you have the visor that goes on the exterior of the cabin. And we had to stiffen up the cabin to make sure that the cabin white structure was reinforced in such a way that we can suspend more mass there beyond just a 15 kilo sun visor. And the mass that we had to suspend meant a lot more than just 15 kilos. So those are some attributes that have given us a chance to take that into consideration, knowing that depending on which self-driving system, there would be a need to have certain perception suite up high. There will be a need for some perception sensors to be a little lower to address for any blind spots and any urban traffic topics. So we really acknowledge the fact that there are a few zones within the cabin where you would see an evolution of it. And even from our 2019 prototypes of an autonomous Cascadia at that point being showcased in Albuquerque area by Torque Robotics, there have been some evolution from that time onwards to what was showcased at ACT by Torque Robotics. The sensor suites have evolved. There are some sensors that have been finalized, and even the entire design has gotten into an evolutionary stage. So I would expect this to be a constant evolution, and we just need to accept the fact that the burgeoning technologies like LiDAR will always be up for an attack when it comes to the evolution of images, and we just need to imaging sensors. We just need to let it play out. At the end of the day, there will be a solution that suits the virtual driver or the self-driving system stack development. And as long as we are designing the truck to be accommodating to those evolutions, we will be able to provide a solution for anyone who wants an autonomous ready Cascadia.
If I heard that right, the cab is going to stay until one of your customers, one of your partners has a clear roadmap or definition of where they want their sensor suite to go and how they view it looking?
I would say in the next few years, we have committed to a current Cascadia raised roof cab. There are some areas where we can look into optimizing it for weight and cost, but that'll be our current path going into a production. And as I said, it'll be immediately challenged by our customers and the market on what can you do in a day cab variant or so. And we have to let that take its course. But current production path is to have a raised roof, 72-inch raised roof Cascadia cabin.
Is the little secret that you're not telling me is because you want the humanoid robots to go in the cab? Is that the secret here?
Definitely not. If at all, that functional objective to have room for a humanoid robot, that did not get to me. But no, definitely the goal is to have enough access to a human driver should they need to move it outside of the operational design domain. What we want is to never compromise the fact that there are going to be situations where a human driver needs to operate this vehicle. We must provide all comfort and safety features to that person, just as we provide today in a regular Cascadia or a human-driven Cascadia.
It's a well-defined strategy. What are your thoughts on the Tesla Semi?
I have not had a chance to drive one yet. Definitely respect anyone who is trying to provide solutions to our customers, especially when it has a potential to decarbonize, in addition to also giving the benefits of a self-driving system. I have a great deal of respect for all our competitors. In fact, at ACT, I was able to look at them all under one roof, nothing but admiration. And I'm a big believer in value creation before value claiming, and more players coming in and challenging the status quo of 5,000 fatalities due to Class 8 truck accidents and the ever increasing cost of moving freight due to driver shortages. Those are real problems. And anyone who is coming onto the table to solving those real problems are going to help us create value. And from that point onwards, we need to let the engineers, the manufacturers, the service technicians, and everybody else who supports the product in making sure we can claim the right value. I see the Tesla Semi or their capability to have a green solution and also take all the self-driving system knowledge from their cars and apply to trucks as a welcome opportunity to set the pace of how these technologies can be realized in the market to a faster rate. And I have not had a chance to drive one yet. Nothing but admiration for not just what's happening in Elon's world, but also what is being done at Volvo, what's being done at Kodiak. All of them are doing some outstanding work. They're all helping us create that value pie, so to speak. And then after that, then we can get into this game of value claiming.
Autonomous trucking in the industry, it's a growing market. It's a healthy market. Consolidation is coming, but overall it's a very healthy market, and healthy markets do consolidate around the winners, which some are your partners, some are not your partners yet, perhaps, but there is consolidation coming, and there's some very large funding rounds that are coming to back up my consolidation theory. When I think about Tesla, and you look at all the breakthroughs they've had with FSD, and I was telling you earlier, when I drove the 12.5.5.1, and I test drove it, I was impressed. And there's some major breakthroughs that are happening with FSD. I believe it's just a matter of time until Tesla cracks full self-driving the camera system. I'm not going to give a date. I don't have a date, but it's getting closer to where it was, and they're eventually going to crack it. When they do crack it and they port it to the Tesla Semi, what happens to the market? Is the market completely go back to the drawing board, or what do you think happens to the autonomous trucking market when Tesla does crack FSD and puts it on the Semi?
That's a good one, and I think it's a very speculatory environment there, and I would say that'll be one of the biggest disruptions that we would have to address as an industry. And when that happens, if that happens, that'll be probably the biggest disruption that we need to address as an industry. There are some fundamental elements that won't change, however. The economics of moving a freight still is going to play a factor when you talk about big fleets wanting to make their asset purchase decision. There are going to be some fleets who are always going to have a diverse portfolio of assets in their organization. So you will still see some impact because of this huge disruption, but you also want to acknowledge the fact that trucks are a means to move a trailer, and the primary aspect of what a fleet wants is a reliable way of moving those trailers from point A to point B. And the tractor units or the trucks that we provide to these fleets must meet the expectations that they set in terms of uptime. It must meet the expectations when it comes to serviceability and residual value after its first life is done. So there are a lot of factors that go in today when a fleet makes those decisions. And autonomy provides them one more lever to have their bottom line that is sustainably growing every single year. And should there be more players coming into this, it'll definitely have an impact. But we want to talk about also an industry that heavily relies on several aspects. And it's also an industry that wants to make sure that they keep a lot of options open. So I would say, even if there is a disruption, it'll not be a disruption, I think, at the rate at which the passenger car industry, it would be probably at a different slope from my personal opinion there.
Let's take this down one more level here. What if they licensed FSD for the trucking industry? What does that do?
Also an exciting what if here. And this would definitely see an accelerated departure of some key players, potentially heavy consolidation from other players. So definitely a very good thought experiment. I'm not able to see how that would impact our vehicle development project, but there are some attributes of software development in itself, whether it is in the level 4 area, or some folks are working on a level 3 plus, some folks are working on a level 2 plus opportunity. So there is definitely an area where licensing different levels of self-driving software so that every OEM doesn't have to invest a lot to create their own unique solution. One must also understand that trucks still rely on an architecture, an electronic architecture that is very specific to each vehicle. So that is why our dependency is going to be different than how a passenger car architecture can be updated or revamped fairly soon. So we are relying on a lot of J1939 protocol today, and we're also heavily reliant on a lot of emission and onboard diagnostics requirements. So there will be some assistance, so to speak, for a complete overhaul. But nevertheless, I don't want to underestimate the probability that somebody could come in and offer software as a service, not only in the level 4 virtual driver area, but also beyond that, even into ADAS. That'll be a very exciting area. Because at the end of the day, licensing one's software would be a very lucrative business model. And I'm sure that it is not just an ambition from Elon and his team, but also many players who are currently working on a level 4 system who would love to license their portion of their code for a level 2 system or even a level 1 system. But we'll have to wait and see. The impediment is going to be on how the vehicle architecture enables.
If you look back in recent history, Nuro licensed their bot stack for Ike to build their autonomous truck startup. I'm actually meeting with the Nuro leadership next week, and everything looks like they're going back into the licensing game. So I'm very curious if that's where they're going. And I will make a very bold prediction here on the record to you. If Tesla does license FSD at some point in the future, you will be able to get Tesla FSD on a Freightliner Cascadia. I don't know when, but I believe that if it does happen, it will happen simply because the market will demand it and your customers will demand it. And when that happens, to me, that reinforces the value of what Daimler Truck has in the Cascadia Freightliner. As an individual who is one of your customers, one of your largest customers actually, he said to me, this is the Cadillac. This is the top. This is the gold one. This is what we want. It's Freightliner Cascadia. I don't want any other. And he said SHIT. I want the Freightliner Cascadia. And that goes a really long way. And if you combine the best of both worlds, Daimler Truck's in a very, very big position to take a significant market share and play a very large role in the future for autonomy. I could see a future where you license FSD, you work with Kodiak, you work with Aurora, you work with Torque, you work with Waymo, where you work with everybody. That becomes interesting because now you're in the business of selling the platform and in your business of selling services on top of that platform. That becomes a big business that your executive leadership in Germany and your shareholders will reward you for because, as I said from that gentleman who's one of your largest customers, you have the Cadillac, and that is the Cascadia. What, in your opinion, I gave you my prediction, but what, in your opinion, is the future of autonomous trucking look like?
First off, thanks for the vote of confidence. And it is really nice to hear that the work that we're doing is actually of value to our customers. And, as you know, very humble to hear those words, and we'll continue to live up to that. The fundamental reason why we got into this autonomous has not changed. The accidents continue to take lives, which can be avoided. That equation has not changed. In fact, one of my dear friends, Sandeep Kaur, you may know him, and he had done a study back in 2014 that he shared with me. The accident numbers from 2014 have not changed. It's been pretty much that 5,000 number has always been around. So we really need to do something as an industry. Therefore, that part of it has not made us take our foot off the pedal. So that's there. We need to do something about the safety element of it. And then the freight efficiency, the demand to move freight more efficiently still exists, and that's only going to keep growing at the rate at which we are consuming and the challenges that we have in finding new drivers. It is very clear to me that if we as a society want to consume, we need to augment today's drivers with autonomous capabilities. Therefore, I see this as an augment to today's key contributor towards freight efficiency, which is a driver. So we definitely will see augmenting the driver shortage with autonomous on certain areas. So I am convinced, not because I'm very bullish that it has a revenue potential like no other area in the past, but I do believe in it because the market needs are there and those requirements are not going away. And the future of autonomous, I would see, or I would hope, is to have very safely built, very reliably deployed trucks and software. It is very important when a technology proves itself in legislation's hands and also in social acceptance hands. Someone once told me a simple Venn diagram, you have the piece of technology, you have legislative or compliance acceptance, and you have social acceptance. The intersection of all three is when you have a beauty. And I remember there's a piece of technology that I really liked, which was a wearable Google Glass. Great piece of technology, But when it was released, I couldn't drive with that because it was seen as something that I cannot drive. So legislation did not help me there. And I couldn't wear it and go to a bar or a club because people would call me a glass hole. So it was a great piece of technology that didn't really, unfortunately, take off. Now we have an opportunity as a technology originator. It is our responsibility. It is my responsibility to make sure the truck is built in a reliable, robust, and a trustworthy way. That is my job, to have a faithful actuator. And then with the help of a self-driving system, we transparently tell what our safety cases, what our cybersecurity measures are. And when that is showcased to the legislators and society, you would have that gem. And we just need to be persistent and be relentless in that pursuit.
I was a glass explorer. I was one of the first people ever to have the Google Glass, and I took some musician friends of mine, and we all went and got glass. And I'd walk around Rodeo Drive, and I would get stopped. People thought I was the weirdest person. I was the surveillance man, all sorts of weird stuff. But I learned a trick. I put a hat on, and I put under the hat. Less people talk to me. And I went to Disneyland down in Anaheim, and I wore it for the entire day. My daughter was very young at that time. And it was the greatest magical thing, because every time she met a smile or saw Mickey, I would just blink and would take her photo. And so me being me, and you know me well enough to know this, so what do? I get in line for Splash Mountain. I have to be the first person in right the front. And I filmed the whole thing through Splash Mountain. And it was the coolest thing in the world. And we still have the video to this day. And I've done some other filming with it. But you were able to get that perspective. The downside was, yes, people call you a glass hole. And the battery life didn't last very well. But if you fast forward to today and you look at the breakthroughs in that technology, Evan Spiegel tried it with the Snap glasses, which Karl Lagerfeld, before his untimely passing, did all the design. It was really well done, but Snap made a flaw, and the same flaw that Google made. Google, you had to get an Android phone, so I had to buy an Android phone, and you had to put it into the Google Photos, which was a pain in the neck. Snap, you could use an iPhone or iOS, but you had to go into Snap. Now with the Meta Glass made by Luxottica with the Ray-Bans, it goes into the Photos app. You don't even have to have a Meta account, and it blends it, and it looks like you're wearing Wayfarers. That's the factory grade truck that you're building at Daimler. All the prototypes that came up to this point, whereas first ones was the Google Glass, then we went to the Snapchat. Oh, that's not going to work. Now we need the Meta Glass, which is the Daimler autonomous ready Cascadia coming off the line. That's where we are in this, and the technology is going to evolve and it's going to change. And I said earlier, and I am going to beat this into people until they listen into submission, that Daimler will play a significant role in the future of autonomy. I will go again on the record that I believe when it's all said and done, for autonomous ready truck class 8 platforms, Daimler Truck, this is global, not just North America, will have over 50% market share globally at some point, and your shareholders will be richly rewarded. Now that I've said my piece, this has been a fun conversation, Suman, as we look to wrap up. You're very, very welcome, and we're having you back on again. You've been fair warned. That's on the record too. You are coming back. What would you like our listeners and viewers to take away with them today, besides going out and buying a Cascadia truck today and then eventually signing up for an autonomous ready Cascadia in the future?
Yeah, first off, thanks, Grayson. It's always fun to listen to you. Talking to you is an added pleasure from my side. So sincere thanks. And also a lot of gratitude in how much you hold Daimler Truck in your regard, and we want to live up to that. It makes me humble and also motivated, so thank you for that. The one thing that I would request your audience is to believe in this piece of technology, but also demand from those playing currently in this field. It is important that you ask questions. It is important that you challenge some of our decisions and ask us to explain why we are doing what we are doing. Ask us to explain the design philosophy, ask us to explain why is the state of the art limiting us from going further. All of that is going to be super valuable to us because we all know that this is the first incarnation of it. And in order for us to have enough energy and knowledge and capability to have the second version of it and the third version of it, we are going to have to solicit input, solicit questions and curiosity. From my experience, the third product that I have designed usually is stellar. The first two are like first couple of pancakes. So we need to make sure that we acknowledge that the first one is a learning opportunity. It has a lot of room for improvement and optimization. And we want to make sure that we collect as many inputs as possible. So if your audience can be curious, ask us questions and demand more, it will propel us to perfection during every iteration.
It's highly important to be curious. It's highly important to imagine, but I'll follow on Suman's and I'll quote Ronald Reagan: trust but verify. The future is bright. The future is autonomous. The future is Daimler Truck. Suman, thank you so much for coming on the Road to Autonomy, and thank you so much for being a listener and being a great cheerleader all these years. Thank you so much.
Thank you, Grace.